Here's an application problem. It says two helicopters leave a heliport at the same time. The first flies 160 kilometers per hour in a direction of 330 degrees. The second flies 200 kilometers per hour in a direction of 220 degrees. After 4 hours, how far apart are the helicopters? Round your answer to the nearest kilometer. Alright, so it is a good idea to start by drawing a picture of the situation. So let's start by doing just that. I'm going to draw my axis because we have to measure and draw angles. We have to draw angles. Okay. Now, typically in these application problems, when they give you a direction in terms of degrees, without any further qualifiers such as northeast, northwest, southwest, or southeast, when they give you a direction just like that, a plain number, which is measured in degrees, that means you measure that from the north instead of from the east. In trigonometry, most of the time we measure angles from the east, right? So if I had like a 30-degree angle, this would be the initial side, and I would draw the 30-degree angle right here because I measure from the east. However, for application problems, it's typically the case that the convention is that you measure from the north. So when they say 330 degrees, I measure from here. So I'm going to rotate then this picture because it's going to be easier for me to draw that. 330 degrees is almost a full circle. It's almost 360. You're only 30 degrees short. So that means I'm going to draw, and it doesn't have to be perfect, but something like this where you have 30 degrees here because I'm short of 30 degrees to complete 360. So let's say this is 30 degrees. I need that to complete a 360. Okay, so that means that the first helicopter is flying in this direction. Okay, now let's draw a picture for the other helicopter. The other helicopter flies in a direction of 220 degrees. So let's rotate that again and draw 220. 220, measuring from here, it's a little over 180. So this is 180 here, a little over. Actually, how much over? 220 minus 180 is 40. So about 40 degrees. About 40 degrees. So you go over 40. So that means this right here is 40. So the other helicopter is then flying in that direction. Okay, the question is, how far apart are these two helicopters? So after 4 hours. So after 4 hours, the first helicopter is here, and after 4 hours, the second helicopter is here. Then what is that distance? So in other words, if we connect these 2 points, what is that distance right there? Okay, we're going to complete this triangle because there's so much information missing. Now let's figure out this angle right here. This angle right here, well, just think about it in 2 pieces. First, this piece right here is, how much is that? Well, if this is a 90 degree and I already have 30, this part has to be 60. That part right there. So the angle formed with the purple and the blue. And similarly, this part right here would be 90 minus 40 because it forms that right angle right there. So it would be 90 minus 40. So this part right there is 50. So the whole thing is then 110. That angle right there is 110. degrees. Okay, now, what is this, the length of this? We can figure this one out because that's the distance traveled by the first helicopter. So if the first helicopter is flying at 160 kilometers per hour and it flies for 4 hours, then what is the distance flown? The distance flown is just going to be 160 times 4, 160 kilometers per hour for 4 hours. So that means this distance right here, that is, this side is 640 kilometers. So now we have that angle, that side, and we can figure out this side. This side right here is the distance flown by the second helicopter, the distance traveled. The second helicopter flies 200 kilometers per hour for 4 hours. So 200 times 4, that would be 800. Okay, and that's the complete picture of our problem. Now I'm going to redraw this, but without all the clutter. What we really have is this triangle, this situation right here. This is 110, this is 640, and this is 800. And our goal is to figure out this side. So let's give it a name. Let's say we call it little c, and then I'm going to call this little a, and this one lowercase b. Okay, note that we have side, angle, side. This is the law of cosines. And this angle right here, because it is opposite to lowercase c, is going to be called capital C. So now we're going to apply the law of cosines to figure out lowercase c. So the law of cosines is going to tell me that this one squared, if I take that as a quote-quote hypotenuse, or a fake hypotenuse, this one squared is equal to that squared plus that squared. Now, because this is not a right triangle, we make a correction. Subtract 2 times the product of the sides times the cosine of the angle between them, which is capital C. Now we plug in our numbers. We get lowercase c squared equals little a 640. Lowercase b is 800. Minus 2 times 640 times 800 times the cosine. The angle is 110. Okay, now let's simplify. This plus that, if you put this part in the calculator, you're going to get 1,049,600. And now this part, if you multiply 2 times 640 times 800, you get 1,024,000. And then cosine of 110. So that means C is the square root of this. Okay, good. That is lowercase c. Now we are ready to enter this in the calculator. So this is going to be the square root, the square root of 1,049,600 minus 1,024,000 times the cosine of 110 degrees. And that is 1,183.143536 kilometers, but they asked us to round it to the nearest kilometer, so that means C rounded is 1,100. 1,183.